Hello, everyone. Thanks for joining us in another GeneXus webinar. Today we have Inside the Mind of a Hacker, where we will show you the mechanisms used by hackers to detect vulnerabilities and exploit them. Today's presenter is Gerardo Canedo. Gerardo is a computer security specialist and computer engineer with more than 15 years of experience in IT consultancy. Gerardo works at GeneXus Consulting as Chief Security Manager and Software Architect. So without further ado, I now introduce you to Gerardo and hope you enjoy the webinar.
Hello, everyone. My name is Gerardo, as Jaime says. Thanks for the introduction, Jaime. And I'm going to talk to you today about how hackers think and how hackers do to hack things. Okay. Nowadays, we are facing more than ever an era and the circumstances of our times where our businesses are facing a lot of information through the internet. Every business function, we are doing something on the internet. It could be working on our business, it could be working with our partners, with our customers. That gives a lot of flexibility and a lot of new features that are really cool, but there also brings some risks. It also helps another people that we are not interested in showing our business we are letting them try to see what are we doing, and sometimes they are able to handle or to change things that we don't want to be changed, or get information about us or our customers that we don't want to share. Okay. A recent study states that 43% of the attacks in 2020 were aimed at web applications. Okay. And why is that? It's because almost any business that has a relevance has something on the internet. And the protocol that we are most used to use is a web application or something through the common websites. So this is something that the hackers know, and they also know that there's a lot of problems in these applications that they can use to get some value from it. Okay, so let's start with a little definition. What are we talking when we talk about a hacker or hacking? From Google, because most this application, most the presentation is made using information that is public, that is accessible for anyone. The only thing is that I have used that information and I know how to handle it, but everything is on the internet. And hacking says the gaining of unauthorized access to data in a system or a computer. Okay. My first question is, are all hackers the same? And the answer is no. They are not all hackers the same. There are different kinds of hackers, and that they do different types of attacks, and they look for something different, any of them. The first type of hacker, which is the most common and is the most widespreading, is the scripty kid. This kind of hacker actually is an amateur hacker. Most of the time, they don't know what they are doing. They're just following a tutorial from internet, Twitch, YouTube, from a friend. Okay, and what they do is to reproduce a series of steps in order to get something. Most of the time, they don't know what they are doing, and they tend to be underaged or young people, but that's not exactly true. Okay, and they can do a lot of damage. We will see in this presentation a lot of very simple techniques that a scripty kid can use to harm a business, because harming a system or accessing a system at the end of the day is harming a business. There also are opportunistic hackers. These kind of hackers have a different approach. They know how to hack one or two vulnerabilities, and they know how to do it very, very well. So what they try to do is to find targets on the internet without knowing which target is actually attacking, and trying to use that vulnerability to get some information, to get some access. After getting that information, after accessing that system, they try to look what they have found and how they can use it. Okay, that's an opportunistic attacker. They came in two flavors. Ones that can use a 0-day or a new knowledge. A 0-day, it's an attack that was not seen before, a vulnerability discovered by itself or by somebody else that has not a patch. Okay, and they try to get some information with that exploit. On the other hand, they can use a very well-known vulnerability that some system administrator or developer had not fixed yet. Okay. We have seen a lot of attack these days with Outlook from Microsoft, that somebody found a very old bug, and a lot of opportunistic attackers have exploited. Okay, then we have a motivated hacker. A motivated hacker, it's a hacker that has some special interest in a target. It could be because of some kind of personal motivation. It could be because the kind of information that is used by that organization. Somebody could have hired him to get into a particular organization, or it could be any other motivation. But it has a special interest in a particular target, and it has time and dedication to invest in that target. It takes a lot of time sometimes to hack something. What you have to do is to keep looking, and they are very good doing that. They use a methodology that we are going to talk about, this methodology, but they use a methodology to get to know which is the easiest way to get through the system or the organization. And they have an advanced knowledge. They can craft their exploits. They can see the environment and program an attack, particularly for that specific application, that specific infrastructure or configuration. And last but not least, we have all this is another completely different game with this when you have a state or a national sponsored hacker. Okay, these kind of hackers work in a different way. They have a sponsor from a nation, and they try to attack or to get into any other infrastructure from a specific target that could be most of the time another nation. Something that has been seen in the last 20 years is that as the time goes by, you can do more harm without knowing less. Okay, in the 90s, if you have a lot of knowledge, you may have some kind of impact on that organization, on that business. But as the years goes by, this curve, this algorithm code, is telling us that people with less skills can do a lot of damage to an organization. Nowadays, this is going to the extreme that somebody that knows pretty much nothing about computers can watch a few tutorials and can start hacking an organization. So, what is the methodology a hacker uses? It is resumed in this special publication from the NIST, which is a public organization from the United States, and it says that an attacking has these phases. Okay, it has very first a planning phase, when you are trying to see what are you going to attack, and you have to understand all the information you can gather from the internet, from documentation, from knowing that organization. Then you go to a discovery phase when you start discovering all the attack surface. When I talk about an attack surface, I'm talking about any endpoint, any kind of port of web application, email address, or whatever the organization uses. Okay, the first thing is to enumerate all that information to get a target where is the part of the endpoint that you believe that is the less straightened one. Okay, and after getting that discovery phase, you commit an attack. You do an attack, and a specific attack to that part. And if you are successful, you get a new attack surface. We will see this in the demos I have prepared for today. But you have a new attack surface, and then you discover your new attack surface, and you start doing that loop once and again. Of course, hackers don't usually report the findings. This is pretty much for ethical hackers, for white hat hackers, when you get this as a consulting services. But in the wild, you don't get a report. Okay, and also the anatomy of an attack. I'm not going to stop in this particular slide now. I'm going to go back to this later. OWASP, which is a non-profit organization with a lot of information about how to attack and how to defend applications in all the spectrum of web, mobile, and IoT applications. They have figured out how the anatomy of an attack is. Okay, and I'm going to this later. Well, so let's start thinking like an attacker. If we have an application with a login, okay, this is a security control. Somebody put this here in order to avoid an authenticated people or bots or whatever threat agent has to get into an application. If we take a look of it, the first thing that we say, oh no, it's user password, we can go further from here. But an attacker doesn't think like that. They start thinking about, okay, I have a username, I have a password. Which techniques can I use to get through this? And the very first attack vector that we have here, it's a dictionary attack. What we are going to do is to try a lot of passwords to see if we are lucky enough to get one hit. Okay? And for that, we don't have to start from scratch. There's a lot of information, as I say, on the internet. There's already a completely working environment called Kali Linux, which has all the tools that you need to start hacking already installed. And you'll need a very deep understanding of those tools. They are completely built in and ready to be used. Also, there's a tool called Hydra. Hydra can do this dictionary attack by just clicking and doing some configurations, nothing very fancy. And also, there's a lot of information on the internet about known users and passwords, a lot of leaks and a lot of information about the statistics on which passwords are the more used. In this case, I'm going to use a very, very simple word list with passwords, which is called ROQ, and it came inside Kali Linux. So I'm going to the demo. I already have here my Kali Linux environment. I have my application here, okay? And I have a login. I can try to get into here, and it says, okay, that password is incorrect, but I'm not going to stop there. I will try to get into the application without knowing the password. Something that a hacker do is to guess things. One thing that is quite reasonable is to believe that there is an admin user. It could be administrator, it could be root. It comes in different flavors, but there's most of the times there's usernames that we already know or we can guess. If this organization is called GeneXus, it may have a user called GeneXus there. Okay? So with that information, I'm going to do something very, very simple. Using the browser, I'm going to show the traffic. I'm going to type there admin. I'm going to pass here. It doesn't matter. Because it's not memory, it's network. And as we see, our browser is communicating with the server to see if the information that we have provided is correct or not. Okay? Which Hydra needs, it's a few parameters from this data that we have here. I have already installed Hydra. It came with Kali Linux. The version that I'm going to use is something that a scripty kid can use, okay? Which is a graphical user interface. It comes in other flavors, in a client, in a command line flavor, and also attackers, more advanced attackers use specific tools for this kind of attacks, like burp proxy, or they can also write their exploit. So the information that I need here is my target. My target is the name of the server. Okay. The port, it's the 80 HTTP. What I have here from all the possibilities that give me that Hydra give me, I'm going to use this one, HTTP post, which is the one I'm using here. As a username, I'm going to use the name admin. I could give a list here with admin, root, or whatever I want, the emails, names, whatever I want. And also, I'm going to type here a word list. I'm going to tell Hydra to use this word list, which it's already shipped with Kali Linux. And I insist you can find a lot of word lists with gigs of passwords from the internet. Then I have to tell Hydra where to hit. In this case, I'm going to hit the login page. Okay, sending which information? Username, as we can see here, username, and the user that Hydra is going to try. In this case is only admin, and the password that Hydra is going to try. And after that, I have to tell Hydra how to figure out if it was successful or not. In this case, I'm looking for a word here in my interface that states that it wasn't successful. In this case, try again. So I'm going to use again. After setting these parameters, I'm going to tell Hydra to show me the attempts that I'm doing, the password guessing. This is for educational purpose, of course. And I'm going to start hacking. In this, now I can relax and wait for Hydra to do its work. I can go to sleep, came back tomorrow, and see what's going on, if I had succeeded or not. What Hydra is doing is trying a lot of very well-known passwords in a relative fast pace. Actually, for the industry, this is really, really slow. There's tools that goes 10 times faster than this. And I'm doing this only from my computer. If I were a black hacker trying to get into this organization, I may have used a lot of these Hydra instances deployed around the world, or in virtual machines, or in clouds, or whatever, to get a high throughput, a lot of password guesses per minute. And after a while, after a while. And remember, most of the time hackers have time. They don't rush. You can leave this working here and do something else, or start or keep on looking the site. It doesn't matter. After a while, we find that we have a hit here. Okay, this time the password is Winnie the Pooh. So I do admin, I paste the password, login. Okay, I'm in. This is the first step. So what was going on here? The first thing is that my threat agent, the one that is posting a thread at my organization, this particular case is a script kiddie. It's somebody who has seen a video how to use Hydra. You can do it now too with this small tutorial. Okay. The attack vector, it was a dictionary attack. I get a dictionary from the internet and try it. There's more complex attacks, but this one, it works sometimes. It's particularly it calls my attention that this kind of things works on the wild. Okay, the security witness of in this case, it was that there was no anti-automation mechanisms. There was no CAPTCHA, no user blocking policy, nothing that challenged me to do something between tries, so I can try a high rate of passwords per second. Okay, what did I abuse? In this case, the login. Okay, but this is a technical impact. This is all these parts are technical stuff, and what does it mean for the business? And this is a very important thing to get from this presentation, that we have to translate this technical impact in something that the business concerns. In this case, it means that an unauthenticated person, an unknown person for us, can do whatever business function the legitimate use can do. In this case, it can do all the administration of the application. It can see the information that administrator can see. Okay. So now that we get into the application, we can start looking at it. And something that caught my attention, because I have already reviewed this application, of course, is that we have an invoice form here. And I can query for invoices. Okay. And when a hacker sees something like this, the first thing that came to its mind is saying, okay, if I have this kind of stuff, most of the times there's a database after this. It's using a database in some way. And what if the developer commit a mistake? What if the developer didn't know about SQL injections and the development tool didn't help that developer to know that they are doing something wrong? What if there's something to attack here? And this is the second phase of my attack. I'm going to attack this with a SQL injection. What is a SQL injection? Is this: we have when we're programming, we have we have to tell the database what information we want and how to filter that information. And sometimes developers do use concatenations of strings. It's still common in 2021. It was common in 2010. And these kind of things, we still see a lot of this when we are doing our assessments. And they are completely harmful for the organization, because when we are doing a query like this, we are expecting our user to insert something like a text. But what if our user, in this case our attacker, use something more complex? For instance, using these commas here. What we have is when the application runs, what it does is to change the information that is going to come back from the database. We change the logic of the query, and doing that allow us to do whatever query we want in the database. Okay, that's pretty serious. Something that you can be thinking now, it's okay, but I don't know SQL. I have to figure this out. There's a lot of information to do a manual exploit on this on the internet. There are very fancy techniques, blind SQL injections, time-based SQL injections, Boolean. There's a lot of information, but the most shocking part is that you don't need to know anything about that. You can use a tool called SQL Map, which is the tool that I'm going to use now, that allow me to exploit that particular vulnerability, sometimes without even notice that that vulnerability was present. So let me show you. We have this web page. I can just pick any web page on my site, and I'm going to tell SQL Map to run against my application. So I'm using the SQL tool, telling it this is the URL you have to attack. If you're successful, get all the information that you can get. I don't matter which information, you just grab it and I'll see it later. Okay? And don't ask me anything. I don't know how to answer your questions. Take all the decisions by yourself. Okay? And after that, the only technical difficulty, if we can call it that way, is to tell the SQL Map that you are the logged user. Instead of logging with using the form, what I'm going to do here is to get the information that is my browser using to identify me, which is a cookie, something that is very, very common, and it's okay to do this. Okay, but you have to take some considerations, security consideration, but the mechanism is completely correct. And I'm going to paste the value of that cookie I'm going to paste the value of that cookie. Here we go again. I'm going to paste the value of that cookie. And I will tell SQL Map to run. Now, again, it's time to relax. I will let the tool to do everything. I don't have to do anything here, just to see. And if it's success, it will tell me we have an injection. And if it can do it, it will take a lot of information from the database. As you can see here, the tool find a way to get into the system. So we have a SQL injection, and with that SQL injection, what it did was to get all the data from the table invoice. This is the first thing that it did. Then the other thing is that it did was to get the information about the table user. And as you can see, we have some information here that we haven't seen before. Actually, we see the admin user here and another user. And also, SQL Map have the ability to see that this particular string means something. We are going to come back to this later, okay? And now it's trying to guess which is the meaning of this string here. And I'm going to cancel it because we are going to use a different attack for that. But when I cancel this attack, it shows me something very, very interesting is that in that database that we have been using, we have another table that was not present on the user interface, which was a credit card table, okay? And we have all the information from that table that was not accessible through the user interface. That's why SQL injections are so harmful for the business. And this is one of the most fashion ways to get information from our organization. From a single user interface with a particular vulnerability, you can get all the information from the database. Okay? So that's pretty nice for an attacker, and that's pretty a problem for the business. This time, again, the threat agent that I used was a scripty kid. I wasn't using nothing very fancy. My knowledge about attacking, the knowledge I used for attacking, it wasn't that much. It could be a get through tutorials. The attack vector that I try is a SQL injection. Actually, I don't know exactly which parameter the SQL map uses to get information, but it did. The witness that we have explored is that there was a text concatenation in a SQL query. And the control that was missing in this case was that the string was used and was input by the user, and there was no prepared statement or sanitization present. We have used the function list invoices, but the business impact that we get was an unrestricted view of all data in the database. Also, the attacker could get complete control of the database, and from that particular server, it could move inside the organization in different ways. Of course, that kind of attack represents the attack of a motivator attacker or an opportunistic attacker that has all its attack working, so it goes from there to some other attack inside the organization. And there was something very interesting here. If we see, we have a field called password, and we have something here that doesn't seem to be a password. And in the next round, we see that between parentheses, we have Winnie the Pooh and this string here, okay? So what does this string mean? That string, actually, it's a hash. A hash was a common way to store passwords on databases and persistence in general without storing the plain text. Without storing the database, the exact plain text, you can store something that applied to a function, it brings a number which is unique. If I put here this password and I apply this function, I will always get this information here. Something important, SHA-1, it's an old version of a hashing algorithm. It has a lot of vulnerabilities. Nowadays, it should not be used, but we still see this kind of hashing algorithms present on systems. And the normal way of thinking this is that, okay, from this function, I get this value, but this value, it has no a P, an A. How do I know this is password? Okay. There's no straightforward way of getting from this information the word password. That's why a builder thinks when it's applying a hash, I'm getting a digest from some information. So if somebody presents me that information, I can see if they know the secret or not. But having the secret, I cannot get the pre-image. Having the image, the calculation result, I cannot see the original data. Well, that's partially incorrect. Why? Because hashes, if you put here password and you execute this function 1,000 times, you will get 1,000 times the same result. What hackers do is to get a lot of these numbers, a lot of computations of these numbers, knowing which is the previous value for getting that hash. In this case, I have these two. So what if I use a technique to try to see which is the password stored in with this value? So we have a lot of tools for doing that. Some of these tools are online, and we can also use specific tools for this kind of cracking. Okay, it's called cracking, the technique to get a pre-image of a hash or a different algorithm from a result. And two of the most famous tools for doing this is Hashcat and Sean the Reaper. In this case, I'm not going to run any kind of tool locally. I'm going to use a website that is called CrackStation. These guys has a lot of hashes stored on the database. So I can paste here my hash. I have to tell them that I'm not a robot. Most of the time, I'm not a robot. So I'm going to this. Okay, I'm not a robot. And I'm going to click the crash hashes. And what CrackStation tell me is that for that value, if you apply the SHA-1 function with this password, you will get it. So I can see what happened, what if I go here and I type the username with that password. Okay, it works. If I try that username with some different password, it wasn't. So what we did was to crack a stored password on the database which was not well stored. Okay, there's techniques for doing this. And what I'm doing here is something very simple, but we are still seeing this on production environments on a daily basis. Okay, now let's think a little more about this beyond the application. What we have gained is information. Okay, this is information that we have now, that we had it before. And we can see that we have an email, we have a password, we have a username, we have a name. What can we do with that information? If we were hackers, something that we can do is try to use that information in some other way. So we have an email and a password. What does it mean? What should I try? The first thing that I should try is to use the fact that people use most of the time the same passwords everywhere. So I can go to Gmail. I can get that email from here. Put it there. And we can use the password here. And voila, within. Okay, so something that we are using here is the fact that a lot of people uses the same password on different sites. You get one site hacked without the scope of that person. That person has no idea that site was hacked, and the information get from there. It could go to the dark web, it could go to the hackers, and somebody can use that information to log into other systems, applications, or whatever with the same information. So this is something uncomfortable most of the time. There's a lot of techniques to avoid this. We have disabled all the techniques that we use for this particular account for this demo, but after the demo, we are going to send it back. Okay, and we get some information, some new information. When we are here, again, what we have to do? Discovery, which means let's start sneaking around the user. In this case, I go to Google Drive and see in Google Drive I have something from work, boring, school, even more boring, private. This word is nice. Okay, and getting here, I get a text file with apparently a lot of passwords from that person. I know a lot of people who do this. Again, there's a lot of ways of doing this in a correct way. In this case, this is something that we have seen a lot on the wild, on the internet, in our ethical hackings. Okay, so here I can start looking for information, credit cards, getting impersonate that person, send emails, whatever I want, and checking the emails, I see that this particular user had a Twitter account. Okay, so let's go to Twitter. And I'm going to start a session. But what happened here? I have no clue of the password. So what I'm going to do is I'm going to abuse from the forgot password feature. I'm going to ask Twitter to send me an email with my password. And because I have access to the email, I can see that I have a password reset code that I'm going to use. I have to use the correct one, which is the first one. Okay, and now I'm going to use whatever password. I forgot my password. Thank you, Twitter, for thinking me. Okay, I am get into that person's Twitter. With Instagram, there's a lot of hacking going on with Instagram nowadays. And most of the times, what those hackers do is to get information about people from dumps of information, as we have gathered from that site, and try to get into those accounts to take control of those accounts. They change the email for the forgot password. They get into your email, get the links, and all that stuff. Okay, and that's pretty much what an attacker do. Okay, there's a lot of attack vectors that are very, very common, and we see a lot in our assessments, which are, for instance, software with no vulnerabilities. This is a software that has been discovered as particular vulnerability, and in our organization, you have that software. Nobody fix it, nobody patch it, so the attacker can use it. There's a lot of APIs and web service nowadays. Angular, React use a lot of APIs, and if those APIs were correctly secure, an attacker can abuse of them and get a lot of information from the organization without getting into those organization servers. Okay, there's another kind of attack called cross-site scripting that allows an attacker to craft an HTML and change the way your page displays, and it calls lure people to get passwords, to execute commands as an administrator. There's a lot of things you can do with a cross-site scripting. Also, there's unsafe configurations. Sometimes when you install a software, an appliance, or whatever, it comes with a default password. We have seen a lot of default passwords on production environments. So if you can go admin, or you can go root tor, and you get into that when somebody forgot to change that password, or all the TLS, all the transport level security of the site or of the service wasn't configured right. So there's a lot of things an attacker can do with that. Other common thing we have seen is security through obscurity, which means that nobody can hack me because nobody knows that I have this endpoint. Nobody knows the key I'm using. Nobody knows. That's a lie. all the obscurity, it goes clear once in a while because somebody left the organization. There's a leak of information for some kind of event. Somebody guessed it. Somebody thinks the way you think, so they reverse engineer the way you did the implementation, and they can assume some things, and with time you get that information. And one of the most the most harmful things are the design failures. If you design your infrastructure, your system, your web applications, your mobile applications in an unsafe way, it's really, really hard to defend that. Sometimes you have to throw away something and get that thing with that application done again in order to not have security vulnerabilities that can put a threat on your organization. So, as conclusion, what I can say is there's a lot of different types of hackers. Who would like to hack me? I'm nobody. Okay. The truth is there's a lot of hackers that just looking for small fishes to catch them. They don't really know you. If you have an endpoint, you have a website, and the tool they are using, they get into it, you are catch. Okay. Also, there could be motivated hackers for some reason, competence, somebody that had a bad experience with you or whatever, that would like to harm you, to give you back that pain, and they do this kind of things. Okay. And you don't need to be a super hacker. Okay. You don't need to be a great guy with a lot of knowledge to attack somebody. With a little patience, a lot of time for reading and for seeing videos, you can hack some things. Of course, you will not be able to hack anything on there, because if the security controls are well positioned, your attack surface will be very, very reduced. Okay. And for organizations, it's very important to detect these vulnerabilities and to fix them before somebody else does it, because somebody else will do it. Okay. Well, thank you for your time and for being with me today. And this is my contact. Anything I can help you, I will be pleased to do it. Okay. And we are open for questions.
Great. Thank you for that great presentation, Gerardo. A bit frightening at parts. I'll make a point of not sharing my details, my contact details with you.
It's too late, Jaime. It's too late. You have to change that password. Your cat's name is not a password.
Sorry.
Change it. Don't worry. I already did it for you.
You did. Thank you. Then send me the password through.
It's going to cost you a few bucks.
No problem. So we have a question there. Thank you. So Angelo Nardone is asking, what is the current password encryption protocol used on GAM, in GeneXus Access Manager?
It's SHA-256 with Assault. Assault, it's a specific value that it makes all this cracking stuff to take a lifetime. Okay, so GAM already addressed that for you. From the chest, you get into the table to get the pre-image of that value. You will need a salt that is stored in the database, and you will have to run hashcat for quite a years to get it.
Okay, good. Thanks again, Angelo, for another question. Is SQL injection prevented on GeneXus?
It's a very good question. The first answer is yes, it is prevented. But, and there's always a but, you as a developer may have decided to use the SQL sentence in some of your GeneXus programs. If you have the SQL sentence written down in one of your programs, you may have turn the autopilot of GeneXus off and execute your own query. In that case, you may be vulnerable to SQL injection. But if you do GeneXus and letting GeneXus to generate all your queries, you are absolutely safe from SQL injection.
Good. Thank you, Gerardo, and thank you, Angelo, for your question. Let's wait a minute to see if there are any more questions. I know this has been an eye-opener for many people, and I'm definitely going to think twice next time I have to choose a new password. So we'll give it a minute to see if we have any more questions. Again, thank you a lot for... Yeah, go ahead, Gerardo.
Sometimes sometimes it's difficult to talk about these kind of things in public. So if you want to discuss something, if you want to ask any particular question, please feel free to contact me. There's no problem. I will not tell anyone. That's my job.
Great.
How do I learn about this topic? We are planning to do a training for GeneXus developers, not to hack, but to build secure software. When somebody is programming and knows which are the threats, it's easy to put there the controls. Okay, some controls are already done by GeneXus, and we just have to be aware of that. Some controls depends on our particular business logic, and you have to take care of it in your system. So we are going to do a training soon, yes.
Great. I think we have another question. Thank you, Sergio. There, Andres. Is there a table in GAM that saves all the login tries?
Yes, there is. You have to set it up because it can grow a lot. But GAM has that feature, and you can also use any other technique for doing this. I know that GAM it's doing some logging too, but yes, you have that information, and you can tell GAM that after 10 attempts, disable this user for 10 minutes. You can do that kind of things using GAM policies.
Good. Let's wait a minute or two for some other questions. Someone's writing. In the meantime, again, thanks to everyone who has joined us this afternoon, or morning or evening, wherever you are. We have people from Italy, we have people from Poland, and we have people from the States as well joining today. So we know there is a lot of offering regarding webinars every day, and we thank you deeply for choosing to be spending your time with us today. There was, I think, there's one more question. One. Yes.
Yes, from Angelo.
Mm-hmm. Is there some kind of tar trap to slow access from a specific IP?
Okay, there's techniques you can use to do that. Most of the time, those techniques we use them using infrastructure, not inside the application. Okay, and you can set that kind of things, but actually, an attacker can use a VPN, for instance, or the Tor network, but a real attacker will use a VPN, okay, from Switzerland, from some kind of country with a lot of privacy, and you will see attacks from a lot of IPs, okay, and that IP will vary minute to minute, hour to hour. So that kind of secure control, it could stop a script kill, but not a motivated attacker. But you can do it. You can put a reverse proxy before your application and making that reverse proxy or an appliance built for that specific kind of attack to identify that there's a lot of connections from a particular IP. There's something that is not what we are expecting, and we can redirect that attacker to another page, for instance, telling it, okay, yes, you log in, and you can play with him too. But all those things require preparation. Something that is very important. If you don't know which threats you are facing, and if you don't know which vectors you are expecting, you cannot prepare a response. And most of the times, the most efficient response is to implement a secure control, and that kind of thing is very, very fun to do. Okay, but and you can motivate. You can motivate an attacker. You can tell the attacker in some way, okay, I know that you're there. Are you still willing to attack me? Okay, because you are not unnoticed, and that could be useful. Okay, but restricting from specific IPs has a lot of workarounds for an attacker.
Good. Thank you, Angela, again for the question. There, we have shared with you a link to the upcoming course on security. We have another question from Sebastian.
Is there any way to escape a dictionary attack? You can do a lot of things to that. Adding symbols to your password, that's common. Okay, but once you get that, in 2012, LinkedIn lost all the passwords, all the chat passwords from all the people registered in LinkedIn, and there was a lot of work going on decrypting that password, rehashing that password, and there was a lot of password with symbols and all kind of stuff. The best thing that you can do is to get the hash of the password the user used and compare that hash to a known vulnerable password. So sometimes people can type down or can use a software to generate a 32 characters long password, and that will be way much secure than that 10 characters password with a capital letter at the beginning and a symbol at the end. Okay? Because hackers know how people think about passwords. So when you're trying to emulate to get that information, you start using that variables. What would that people do? Okay, so symbols, number, capital letters, lower letters, it helps. But the most important thing is to be sure that that password has not been leaked before. And that could be achieved using services on the internet, which are completely legal, and it's a very good service. You can get all the hashes to a database, and you can compare them offline from the internet to see if that hash is inside a password list that was already leaked. Okay, I'm sorry, I'm afraid you cannot use this password here. You better choose another one.
Great. Thank you, Sebastian, for the question. We are now in the hour. So again, thank you a lot for being with us today. Gerardo, thank you for a very insightful and practical presentation. I'm sure all the attendees have taken a lot of food for thought, and we hope this will help them improve security in their organizations and in their personal lives as well. So Gerardo, thank you a lot. Everyone else, you know that we have the webinar site in GeneXus. You can check this webinar, which will be uploaded both on our webinar site and on our YouTube channel, so you can relive it. And please keep updated of all the upcoming GeneXus webinars. Gerardo, a pleasure again. Thank you very much.
My pleasure. Thank you. Thank you all for your time. I'm here to help you if you need it.
Perfect. Bye-bye, everyone.
Bye.